This is our last video for lesson 26, and there were only 2 of them. This is about approaching multi-step problems for area and volume. And of course, I've got links in the description to help you if you need it for previous or other helpful videos. We can use logic and common sense to find the solution to multi-step problems. A blue cube is in a box. What is the volume of the empty part of the box? What we do is we find the volume of the blue cube and then the volume of the box, and we find the difference. We use subtraction. For the volume of a cube, we use length times width times height, so we're going to have 3 times 3 times 3. So the blue cube is 27 inches cubed. For the box, it's also length times width times height. So we're going to do 8 times 3 times 3. That's going to give us 8 times 9, which is 72 inches cubed. We find the difference between them. We subtract the blue cube and get 45 inches cubed for the empty part. So we know that's 45 inches cubed. Okay? To find the area of a 6-foot wide concrete walkway around a swimming pool, well, area is length times width. There's 2 ways to do this. We can use subtraction or we can use addition. If we do subtraction, it's going to be just like we did with this box and the blue cube. We find the area of the big rectangle, 24 feet by 32 feet, as if that center was not there, as if it was just one big white rectangle. Then we do the 12 times 20, and we find the difference. 24 times 32 is 768 square feet. 12 times 20 is 240 square feet. We subtract the blue center part, and we get 528 square feet of walkway around the swimming pool. For addition, we can find the area of the walkway by splitting it into 4 rectangles and adding them. We have 1, 2, 3, 4 rectangles. We know that it's a 6-foot wide walkway, so we know that's 6 feet, that's 6 feet, that's 6 feet, that's 6 feet. And we know that's 12 feet, so we know that's 6 by 12. We know this is 6 by 32. That's 6 by 32, so that's got to be 6 by 12, just like that side, right? We do our multiplication. We find our square feet for each rectangle. We add them up, and we get the same answer, 528 square feet. I personally think it's easier to subtract the missing part, okay? But you might find times where this could be helpful, all right? Here we've got a room, and we can see this is going to be carpeting, that's going to be tile. Here's the door, and they're going to tile right inside the door. Well, that's a good idea. That way when you come in with wet or muddy or snowy boots or shoes, it doesn't ruin the carpet, right? And a foyer will be tile and the rest of the room will be carpeting. How many square yards of carpeting is needed? Well, it's asking for square yards, but look, this is in feet. So we convert first. There's 3 feet to a yard, so that's going to be 5 yards. That's going to be 6 yards. That's going to be 2 yards, and that's going to be 2 yards. We do our 5 yards times 6 yards and get 30 square yards. We do our 2 times 2 and get 4 square yards. And we find the difference. 30 square yards minus 4 square yards is 26 square yards. So what you have to be careful of is, in a square yard, there's 9 square feet. And people don't think about that, but yeah, there are. So it's a lot easier to convert it first into yards. And even if this was 16 feet, then that would be 5 1/3 yards, wouldn't it? So you could use fractions or decimals, right? All right, here we've got a garden and some grass. We can see this is 12 feet, that's 20 feet. It's going to be 3 feet wide, see? We can either use subtraction or addition to find this. We can do the 12 times 20 and then split this into 2 rectangles with a little dotted line here, an invisible make-believe line. Turn this into 3 times 20, and 12, take away that 3, means that this rectangle is 9 feet tall, isn't it? So it's 9 by 3. So we can add the 3 times 20 and the 3 times 9 and get 60 plus 27, which is 87. The entire thing was 12 times 20. We subtract it, and we find out that the grass is 153 square feet. Now we can also say, okay, well, if that's 3 feet and the whole thing is 12, then from here to here on the grass is 9. And if this whole thing is 20 and that's 3 feet, from here to here in the grass is 17. And we could do 9 times 17 and get our 153 square feet of grass. See? Either way, we're going to get the right answer. All right? It's whichever is easiest for you. Now, here we've got a drawing, and here's a tree trunk, and we want to plant flowers around it in a garden that's 2 feet wide going around the tree trunk. And you can see the tree trunk is 2 feet across in diameter. What's the area of flowers around the tree in square feet? Well, the area of a circle is pi r squared. Pi times the radius squared. Well, we don't have the radius, we have the diameter of the tree trunk. And we have a circle inside of a circle. So what we do is we find the area of the big circle as if that tree trunk wasn't there, and to find the radius of this entire big circle, we take that 2 feet and half of this one's diameter, so it'd be a 1 plus the 2, so our radius would be a 3. So we've got 3.14 for pi times 3 squared. That's 3.14 times 9. Now we have to use an approximate symbol because of that pi, don't we? We have 28.26 for the area of the large circle for the entire thing. Now we need to find the area for the tree trunk and subtract it from there. Then we'll know the area of the flowers, won't we? Well, we know that the radius is a 1 for just the tree trunk. So we're going to do 3.14 times 1 squared. Well, 1 squared, 1 times 1 is 1. So we just have 3.14 times 1. And that's going to be about 3.14, isn't it? We find the difference, and we find out that the area for the flowers is approximately 25.12 square feet. Okay? All right, here we have a rectangle, and it's telling us one box of 6-inch square tiles contains 24 tiles. How many boxes will be needed to tile this floor? Well, this is 10 feet, that's 12 feet. So we can do 10 times 12 and get 120 square feet, but it's telling us that the tiles are only 6 inches. So in 1 square foot, if each tile is 6 inches by 6 inches, then there's going to be 4 tiles to each square foot. So that means once we find the area in square feet, we need to multiply that by 4 because there's 4 tiles in each square foot. So we have 120, 10 times 12, times 4. So that's 480 tiles, but we're not done. It's asking how many boxes are we going to need, and there's 24 in each box. So out of the 480 tiles that we need, we split it, we divide it by 24 per box, and we find out we need 20 boxes of tile. See? So it's important to know that there's going to be 4 of these tiles in each square foot because they're 6-inch tiles. Okay? Emma is mailing a cylindrical vase to her aunt as a gift. She mails it in a rectangular box. How many cubic inches of packing foam does she need around the vase? We're going to find the volume of the vase and the volume of the box, and we're going to find the difference in cubic inches. So for volume of the box, we're going to do length times width times height. That's 5 times 5 times 12 for the height. That's 300 inches cubed. The vase is telling us it's got a 2-inch radius and it's 10 inches tall. We're going to do pi times the radius squared times the height. So that's 3.14 times the radius of 2 squared. So that's going to give us 2 times 2 is 4 times the height, 10 inches. We're going to get 125.6 cubic inches. Now we need to find the difference between the two. Then we'll know the empty space around the vase. 300 minus the 125.6 is going to be 174.4 inches cubed of packing foam she's going to need around the vase. All right? All right, so I wanted to throw this last one in here. We have a book here. We can see that this part of the book, the binding part, is 1 inch across. It's 10 inches tall and 8 inches across this way. And it's asking us how many square inches of area does the book's cover have? So the reason I'm showing you this is I want you to be careful on word problems that give you a diagram. This book cover is in the back too, isn't it? Not only do we have this 1 inch wide and 10 inch tall binding side that needs to be considered with the front, but there's a cover in the back of the book. So it's telling us that it's 10 by 8. So for the front, we've got 8 times 10. For the side binding, we've got 1 times 10, and for the back, we've got 8 times 10. We add all of these up together, 80 plus 10 plus 80. So we know the cover is 170 square inches. So be very, very careful when they show you a drawing or a diagram. Don't just think that we're talking about the front here. You have to use common sense and say, well, the book's cover goes all the way around the book, doesn't it? Okay? So you should now be ready to do the skill focus on page 311. And remember to make sure that your answers make sense and use the correct formulas. Make sure if you're looking for area, you use an area formula. When you're looking for volume, use a volume formula, okay? There's going to be links to these videos in the description. I linked 9.4 and 9.5 in the previous video, but now I'm going to link 9.3 along with it because that's going to help you. And if you're really confused, you can go back to lesson 23. There were several videos for lesson 23 that talked about area and volume, and there'll be a link to the previous one that we just did for irregular shapes. Our next lesson is 27A. We're going to talk about the Pythagorean relationship and hypotenuse of a right triangle and legs. And this is the last lesson for GED. It's going to be about 4 videos, but we're now going to be at the very last lesson for the GED before you can take the test. All right? So we just have a handful of videos left. You're almost there. Make sure you understand everything before you move on to the next lesson. Do the skill focus, try your best, follow the instructions, and you'll be okay. And I'll see you next time. Bye.